In this lecture, we will discuss about the Raoult's law. First, we will discuss Raoult's law for that solution in which both solute and solvent are volatile. Solute and solvent both are volatile. So, vapor pressure will be from both solute as well as solvent because both are volatile. Suppose vapor pressure of solute will be P1 and vapor pressure of solvent will be P2, that is in the solution. Then we can say P total is equal to P1 plus P2. Once more, this is for solute and this is for solvent. So P total is equal to P1 plus P2. But as I told you that the solute and solvent both are volatile, so vapors of both will be formed. So now we can say that P1 proportional to X1, that is pressure of solute is proportional to mole fraction of solute. We will get P1 is equal to P1 naught X1. Here P1 naught is the vapor pressure of solvent of solute in pure state, because we have taken P1 for solute. That is why P1 naught will be vapor pressure of solute in its pure state. So we have got P1 is equal to P1 naught X1. Same way for P2. P2 is proportional to X2, that is pressure of solvent is directly proportional to its mole fraction X2. Therefore, P2 is equal to P2 naught into X2. Here P2 naught is the vapor pressure of solvent in its pure state. Now, according to Raoult's law, as I told just now, that P total is equal to P1 plus P2. If we substitute these values, P1 and P2 values, we will get P1 naught X1 plus P2 naught X2. So P total is equal to P1 naught X1 plus P2 naught X2. As we know, X1 plus X2 is equal to 1. Total mole fraction is always 1. We can write X2 is equal to 1 minus X1 and X1 is equal to 1 minus X2. So we can get two different formulas. P is equal to P1 naught. X1 we will keep X1, but X2 we will write 1 minus X1. 1 minus X1. So one formula is derived. Now we can write P1 naught X1 plus P2 naught into 1, that is P2 naught, minus P2 naught X1. So from this we will get P2 naught and plus from this X1 is common, then we will get P1 naught minus P2 naught. Once more, P is equal to P2 naught. Now from both these X1 is common, so P1 naught minus P2 naught. This way we can find out the total pressure by utilizing this formula. In the same way, if we write X1 is equal to 1 minus X2, even then we can get this type of another formula. But for solving the numericals, this is the best formula you can utilize. P is equal to P1 naught X1 plus P2 naught X2. From this type of equation, that is P is equal to P2 naught plus x1 P1 naught minus P2 naught, we can say that total pressure is directly proportional to mole fraction of either solute or solvent. Now we will discuss the graph related to vapor pressure and mole fraction. For the same condition, means both solute and solvent are volatile. We have the formula P is equal to P1 naught x1 plus P2 naught x2. If a graph is plotted of vapor pressure, mole fraction and vapor pressure, then if we keep x1 is equal to 1, then what happens? P is equal to P1 naught plus x2 is equal to say 0. So this term will become 0. So we will get P is equal to P1 naught. P is equal to P1 naught. Suppose say it is P1 naught. Same way, if we write x2 is equal to 1, here x2 is equal to 0, here x1 is equal to 0, then see what happens. P is equal to, let us see, x2 is equal to 1 but x1 is equal to 0. So we will get this term to be 0 plus P2 naught x2. But since x2 is equal to 1, so we will get P2 is equal to, P is equal to P2 naught. Say the point is here, suppose. Then by joining we get the graph like this way. P is equal to P1 plus P2, or we can take P is equal to PA plus PB. So this will be the graph for both volatile solvent and volatile solute. Now to understand this Raoult's law for both volatile solvent and solute, we have one numerical to solve, by which we can understand it in a better manner. Also we have to remember, if we want to find out the mole fraction of solute or solvent in vapor phase, that is in composition, then say P is equal to Y1 into P total. P1 is equal to Y1 into P total, and for the another component P2 is equal to Y2 into P total, then Y1 is equal to P1 upon P total, or Y2 is equal to again P2 by P total. So from this formula we can find out the mole fraction of either solute or solvent, that is both are volatile. We can find out the mole fraction in vapor phase also. To understand, again we have a sum. See, in the numerical what is given to us, benzene and toluene forms ideal solution. Vapor pressure of pure benzene is 50.71 mmHg and vapor pressure of toluene is given to us 32.06 mmHg. If 80 gram of benzene and 100 gram toluene are mixed, we have to find out the mole fraction of benzene in vapor phase, as just now I discussed in this topic. Now we will study the example. How to solve the example? Create the solution. Step number 1. First we will write the data which is available. Vapor pressure of pure benzene is equal to 50.71 mmHg. Now second point, vapor pressure of pure toluene is equal to 32.06 mmHg. We will write the gram of benzene, 80 gram benzene and 100 gram toluene. This is the data available to us. Now in step 2. What can be done in step 2? Find out the moles of benzene and moles of toluene. Moles of benzene, we will get 80 gram of benzene divided by 78 gram. So we will get the moles of benzene. And moles of toluene, we have 100 gram. 100 gram of toluene divided by its molecular mass 92. So we will get moles of benzene and moles of toluene. Now in the third step, find out the mole fraction of benzene as well as mole fraction of toluene. See, mole fraction of benzene, moles of benzene divided by again moles of benzene plus moles of toluene. Same way, if this answer is available, then if we subtract this answer, that is mole fraction of benzene, from 1, we will get the answer for mole fraction of toluene. 1 minus mole fraction of benzene. We will get the answer for mole fraction of toluene. After doing this, we have to find out the mole fraction of benzene in vapor phase. So for that purpose, as I told you, that step 3, what to do in step 3? First of all, we have to find out, once we have find out moles of benzene, and then we have to find out vapor pressure of benzene. How to find out vapor pressure of benzene? Say P is equal to Y1 into total pressure, as discussed before. Say pressure of benzene is equal to Y1 into total pressure. This we will get from P is equal to P1 naught X1. Again I teach you what is P1 naught and X1. X1 is the mole fraction of benzene, and here P1 naught is vapor pressure of benzene in pure state. So once more I revise, please try to understand. See, suppose we have P is equal to P1 naught X1. P1 naught is the vapor pressure of benzene in pure state, that is already given to us, 50.71, and mole fraction value from this calculation we will get. Just multiply, we will get the P total in vapor phase, because we have to find out the mole fraction of benzene in vapor phase. That is why it is required to be done. Now, if this value we will put here, and from this we will get Y1 is equal to P, that we will get from here, and total pressure. Total pressure we will get by P is equal to P1 naught X1 plus P2 naught X2. So listen, what is P1 naught? Once more I speak, it is vapor pressure of benzene in pure state. X1 is the mole fraction of benzene. Same way P2 naught is the vapor pressure of pure state for toluene, and X2 will be the mole fraction for toluene. From this we will get P total, and we will get Y1 is equal to P divided by P total. From this formula, P divided by total pressure, we will get the mole fraction of benzene in vapor phase. Once more I teach you the numerical. What you need to do in step 1, write down all the data which is available to you. In step 2, find out the moles of benzene and moles of toluene. In the next step, you have to find out mole fraction of benzene as well as mole fraction of toluene. Now, before doing step 3, you have to find out P total by just using this simple formula P1 naught x1 plus P2 naught x2. If we say P1 naught for the benzene, then x1 will be the mole fraction of benzene. P2 naught, that is the vapor pressure of toluene in pure state, then x2 will be its mole fraction. After getting this value, we will go for the third step, that is we will find out P is equal to Y1 into total pressure. But what is P? Then P1 naught into x1. Here as I told you that P1 naught is the vapor pressure of benzene in pure state and x1 is the mole fraction of benzene. You will get the answer for P. Now using P is equal to Y1 into total pressure. What is Y1? That is a mole fraction of benzene in vapor phase. So Y1 is equal to P divided by P total. Also you want to find out the mole fraction of toluene in vapor phase. Just remove this answer from 1. You will get the answer for vapor mole fraction of toluene in vapor phase. Now we will study another case of Raoult. It is a special case, Raoult's case in gaseous phase. Raoult's law in gas phase. So we can consider Raoult's law as a special case of Henry's law, because here in this case we have gaseous solute and a liquid solvent. Then we will get P is equal to P1 naught x1. We will get P is equal to P1 naught x1, where P1 naught is the vapor pressure in pure state and x1 is the mole fraction. Vapor pressure in pure state and x1 is the mole fraction. P is the partial pressure. If we compare this formula with Henry's law, we get P is equal to Kh into x. In Henry's law, we had P is equal to Kh into x, and for Raoult's law, we get P is equal to P1 naught x1. On comparing this, we can say here Kh is equal to P1 naught. Now we will study third case for Raoult's. Raoult's law for non-volatile solute in solvent. For this, we have to understand, if we have compound like sodium chloride or say KCl or say glucose or urea, any of this compound, if it is dissolved in water, what happens? We have to discuss that when any of this compound, when it is dissolved in water, vapor pressure of solution decreases. Now first we will understand why vapor pressure of solution decreases. Because take a beaker or a vessel in which only water molecules are present first. So only water molecules will be evaporated because there is no any solute present in it. So vapor pressure will be because of only pure solvent molecules, and that will always be more. But in the second container or second vessel or second beaker, take solute and solvent. So less solvent molecules will convert into vapors, and because of that the vapor pressure observed by the solution will always be less than that of pure solvent. In this case, the total pressure will be because only of that volatile component, not because of non-volatile component. So we will get P is equal to P proportional to X1. On removing, we get P is equal to P1 not X1. So when we consider Raoult's law in gaseous phase, then we get the formula P is equal to P1 not X1 only. And if we draw the graph, then the graph will be of this manner. Why? Again, this is a graph of mole fraction versus vapor pressure. The graph will be a straight line. Why? Because if we keep x1 is equal to 0, then we will get P is equal to P1 not only. And if we keep x1 is equal to 1, we will get P is equal to P1 not. Thank you.